Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Soraya Ananta Prabhawati Ningrum from Jember, Indonesia. I would like to present our research. The title is Reliability Index Evaluation of Distribution System using Section Technique Method at Penyulang Watu Ulo, PT PLN Jember. In the International Conference on Electrical Engineering, Computer and Information System, the author of this research is the first, Mr. R.B. Muhammad Ghazali, the second is Ms. Soraya Ananta Prabhawati Ningrum, the third is Mr. Suprihadi Prasetyono, and the fourth is Mr. Imawan Wicaksono from Electrical Engineering, University of Jember, Indonesia. Okay, the first is abstract. The distribution system often experiences interruption or failures that cause outage. Failures that occur can affect the reliability value of a distribution system, so this will interfere with the continuity, availability, and quality of electrical power distributed to customers. An effort that can be made to handle it, that is evaluating the reliability index of electrical power distribution system. Therefore, it's necessary to calculate the reliability index of distribution system, especially at Penyulang Watu Ulo in Jember or Watu Ulo feeder. The method that used in this research is section technique method, so it will divide it into the area on this feeder into several parts or section based on load breaker switch or LBS attached to the feeder. Okay, next, the second is introduction. The distribution system is one part of the distribution process electrical energy from the generating system to the load or consumer. Distribution systems are more frequently disrupted when it's compared to the transmission system and generating system based on published research on 1991. And then to find out and handle the failure of a distribution system, it's necessary to identify the failure by determining its reliability index, that's called by SAIFI or System Average Interruption Frequency Index, and SAIDI or System Average Interruption Duration Index. Watu Ulo feeder is located in the networking area of the PT PLN Ambulu. It's a supplier in the southern part of Jember and distributes electrical energy to consumers, including shops, banks, and households and any other. In addition, the area served by Watu Ulo feeder is also a tourist area and small medium industry, or in Indonesian called by Industri Kecil Menengah or IKM. And the customers served by Watu Ulo feeder are 25,413 customers, which are divided into 69 load points. This feeder also has a length of 14.081 km circuit. And this is a single line diagram of Watu Ulo feeder. And from this picture, we all know that 69 load points are scattered at several points with different code in each load point. And from this picture too, we all know too that there are two recloser. There is Pancakarya and Glory recloser, and 5 LBS. Okay, next is research method. The first is research design. Research design is what we do in this research. The first is literature study, data collection, calculation, and analyze data, and then simulation using ETAP software. The result of the data collection stage will be used in the processing and calculation as follows: calculation of the failure rate of load point of each section, calculation of the rate of repair of the load point each section, and calculation of the index values of safety and SAIDI, and then calculation of the total reliability index of the distribution system in feeder. The next research method is by comparison of reliability index calculation result using the section technique method with PLN standard number 58 1985, and comparison of calculation result using the section technique method with simulation result in ETAP software, both before reconfiguration and after reconfiguring single line diagrams. And then the result and discussions. The first point is calculation of reliability index of distribution system using section technique method, referring to the large number of customer load points and the value of the failure rate. The symbol is lambda, and the repair rate, or the symbol is U. It can be known the reliability value of both SAIFI and SAIDI system is in each section. And from this table, we know that the total of SAIFI is 4.68091 times per customer per year, and the total of SAIDI is 14.62139 hours per customer per year. And this is the comparison graph of calculation result using section technique method with SPLN. And the white color is section technique method, the orange color is SPLN or PLN standards, and the green color is IEEE standard. From this graphic, we can see that SAIFI values exceeds the maximum PLN standard and IEEE index limits. And from this graphic too, we can see that SAIDI values exceeds the maximum IEEE index limits. And the second point is modeling single line diagram or SLD on ETAP software. From the test and the simulation result on the ETAP 12.6.0 FAIRS software, the value of SAIFI is 4.8229 times per customer per year, and SAIDI is 8.1993 hours per customer per year. And there is a picture of figure parts of a single line diagram before reconfiguration on ETAP software. And from the calculation and simulation result on ETAP software, it can be seen that there is a need for improvement or reconfiguration of the system at the Watu Ulo feeder, because the result obtained exceed the limits of the standard, PLN standards and IEEE standards. A repair or reconfiguration of its improvement is to add an automatic reverse cover, or in Indonesian is penutup balik otomatis or PBO, in the form of a recloser to the section that has the lowest and add some fuse cut out or FCO at several points on the feeder. And the third point is reconfiguration single line diagram of Watu Ulo feeder. There is a picture. The reconfiguration was done by adding 22 fuse cut out or FCO. 22 pieces of FCO were added at several points of the line. The determination of the point in installing this additional equipment is carried out based on the locations of the distribution transformer and the size of the capacity of the customer. Based on the simulation result after doing the reconfiguration by adding 22 fuse cutout and increased level reliability was obtained. The ZIV index is 2.9215 times per customer per year, and SID is 7.7674 hours per customer per year. The fourth point, comparison of simulation result on ETAP software with PLN standard. ETAP software was compared with the PLN standard. The table below shows that the SIV index value from the simulation before reconfiguration is above or exceeds the maximum limit of the PLN standard as for the SID index. But after the reconfiguration, if it's compared with PLN standard, so that's said to be reliable and the improvement may have been achieved. Okay, the last is conclusions. The first conclusion is based on the result of calculation that have been carried out using the section technique method. The ZIV reliability index was obtained at 4.68091 times per customer per year, and SID is 14.62139 hours per customer per year. The second conclusion is based on the calculation result obtained when viewed from the PLN standard. The reliability index at Watu Ulu feeder is categorized as less reliable. And the last or the third conclusions, based on the simulation result on the ETAP software after reconfigurations, the SIV index fell by 39.42% by 2.9215 times per customer per year. And the SID index decreased by 5.26%, which has 7.7674 hours per customer per year. That is, the reliability of the system after reconfiguration is improved when compared to the before the reconfigurations, and the improvement made to the simulation have been achieved because it has met the standard of PLN, standard number 58 1985. Okay, this is our the presentation about our research, and I will say thank you. Wassalamualaikum warahmatullahi wabarakatuh.